During the interval, we have the sixth of 10 conversations in which the late Jacob Bronowski related to George Steedman his personal account of the discoveries and philosophies of the 20th century. Jacob Bronowski was born in Poland in 1908. When he was 3, his family moved to Germany, and when he was 16, they arrived in England. In 1927, he went to Cambridge to study mathematics. It was a place and a period marked by a ferment of discovery. His work as a mathematician took him into secret government service during the war, and eventually to America. So far in this series, Dr. Bronowski has compared the mind of 20th century man with that of his 19th century predecessor. After examining the discovery of the electron, the quantum theory, and the theory of relativity, he described how pattern, growth, and shape are important when considering the structure of energy and the structure of matter. Last week he suggested that Chadwick's discovery of the neutron provided modern man with a dissecting knife, which allowed Cockcroft to split the atom and led to the patenting of the atom bomb in 1933. This week Bronowski considers the way in which that bomb was to be used, and how the nuclear explosion was the result of a fight for freedom. His report for the Chiefs of Staff, the effects of the atomic bombs at Hiroshima and Nagasaki, required him to be among the first to examine the aftermath of the world's... During the interval, we have the sixth of 10 conversations in which the late Jacob Bronowski related to George Steedman his personal account of the discoveries and philosophies of the 20th century. Jacob Bronowski was born in Poland in 1908. When he was 3, his family moved to Germany. When he was 16, they arrived in England. In 1927, he went to Cambridge to study mathematics. It was a place and a period marked by a ferment of discovery. His work as a mathematician took him into secret government service during the war, and eventually to America. So far in this series, Dr. Bronowski has compared the mind of 20th century man with that of his 19th century predecessor. After examining the discovery of the electron, the quantum theory, and the theory of relativity, he described how pattern, growth, and shape are important when considering the structure of energy and the structure of matter. Last week he suggested that Chadwick's discovery of the neutron provided modern man with a dissecting knife, which allowed Cockcroft to split the atom and led to the patenting of the atom bomb in 1933. This week Bronowski considers the way in which that bomb was to be used, and how the nuclear explosion was the result of a fight for freedom. His report for the Chiefs of Staff, the effects of the atomic bombs at Hiroshima and Nagasaki, required him to be among the first to examine the aftermath of the world's first nuclear attacks. The program is introduced by George Steedman.
In 1939, it became clear to all of you that it really was possible to make a really viable atomic bomb.
Some of us. Yes, it became clear to some people.
There was an article in Discovery, a fairly popular English journal, in September 1939 about it.
Yes, but it was an English journal. In America, there was more doubt about it than there was in England. The events that followed are well known. That Leo Szilard, to whom I've already referred, first of all, tried to get publication of new material on atomic fission suppressed by mutual consent of all scientists. In that endeavor he failed. He then went to see Enrico Fermi, a refugee from Italy who had meanwhile arrived in the United States, and he and Fermi, between them, decided that the President of the United States ought to be made aware of their fear that the principle of the atomic bomb was being acknowledged in Europe and that the Nazis under Hitler might be making a bomb. Szilard was left to write a letter to President Roosevelt And since it was thought that neither Szilard's nor Fermi's name carried much weight in the United States, they took the letter to Albert Einstein, who, if I remember rightly, in August of 1939, but I may have the month wrong, signed the letter and had it given to Roosevelt. The letter said, "Recent experiments make it probable that a chain reaction can be made to work and an atomic bomb can be made. There is evidence that the Germans are working at this, the chief evidence being that they have prohibited the export of uranium ores from the newly conquered territories in Czechoslovakia. We therefore think that the United States ought seriously to consider whether it ought to make an atomic bomb so as not to fall behind the Germans, because an atomic bomb would be a war-winning weapon." And what we can call in another sense the chain reaction started from that letter.
Given that the original observation which made a bomb possible was made in Germany in 1939, and what you said about the German work, why was it that American scientists got onto making a practical bomb and the Germans didn't?
That's a very complex question and is answered by different people in different ways. I myself think that the best answer was provided by a Dutch atomic scientist called Housemet, who wrote a book called Alsos, the code name for the mission on which he was engaged, the mission having been one in which he examined all the German documents and German witnesses. Let me explain to you what the dispute is about. The Germans failed to make a bomb because they didn't ever discover that a chain reaction of explosive force could be made to work. A chain reaction of explosive force requires you to build an arrangement which uses slow neutrons. But there is a simpler arrangement which uses fast neutrons, which will make an atomic reactor. So the Germans discovered the secret of making an atomic reactor, but not the secret of making an atomic bomb. They are related secrets, but they're not quite the same. We know this to be true because when the German atomic scientists were in England after the fall of Germany, and the news came over the radio that the Americans had dropped an atomic bomb at Hiroshima, we know that the Germans all laughed and said, "Typical Allied exaggeration, they just dropped a reactor and they call it a bomb." They didn't know that you could make a bomb. Now, some Germans claim that they weren't trying to make a bomb. Well, I don't believe that. Houseman didn't believe that. No, it was a failure. We even think we know the technical reasons why they failed. The Allies did not fail. They both made a reactor in which they made plutonium, which was what was used in the second bomb, and they also succeeded in making an explosive reaction out of uranium itself in the first bomb that they dropped. Why did the Allies succeed? They had a much freer organization. The two chief architects of the bomb in the United States were Leo Szilard, a Hungarian refugee who, even at the time the bomb was made, was still not an American citizen, and Enrico Fermi, a Italian refugee who was also not yet an American citizen. It was inconceivable in Nazi Germany that two foreign citizens, one of whom was a Jew and the other who was not a Jew was married to a Jewish wife, should be allowed the laboratory facilities, let alone the authority within the scientific world on which the successful carrying out of any enterprise depends. And that's not an enterprise like making a bomb. I mean, you could be making a human being or a baby. The fact is that in Germany, even the making of babies tended to be regarded as an Aryan privilege. And if that's what you believe, you'll lose the war. You'll lose any enterprise which depends on communal trust and cooperation.
Now, the 19th century image of the scientist was a Frankenstein image, that the scientist was powerful, mechanistic, and contemptuous of human values. And yet you say that in this most terrible thing of all, this atomic bomb that has dominated my children's thinking, was the product of human freedom.
That's right, and it's true. Does that seem a contradiction to you?
It does, I think, to a lot of people.
Well, again, I'd like to talk about this at first hand. First of all, I knew Szilard very well and Fermi a little. They were both extraordinarily delightful people. Fermi, for instance, was a great athlete. He need not have left Italy. He had won the Nobel Prize. Mussolini wasn't going to touch him. He wasn't even going to touch his wife. Fermi left because when Mussolini became an ally of Hitler's, Fermi had had enough. Szilard, whom I knew very well, who was my colleague in the last year of his life at the Salk Institute, and who in many ways was the inspiration of the Salk Institute, was actually instrumental in bringing me to the Salk Institute because I was the first scientist who talked about human values. And I talked about human values because I went to Nagasaki and Hiroshima in 1945. I saw what the bombs had done, and I was so aghast that I decided that it was not only necessary not to do such work, but to spend the rest of one's life speaking out against it. How was the Salk Institute founded? By people like Szilard and me, who said, we've done all the physics we're ever going to do. We're now going to do biology. We're going to do a subject which does something to bring to the idea of life the same sense of devotion and passionate intensity which we have brought to the understanding of the physical world. But when we brought it to the understanding of the physical world, we were acting with that loyalty to human values which the bomb itself carried. That seems an odd thing to say, but I must spell that out. Between 1939 and 1944, so far as we knew, there was a possibility that the Germans would come up with an atomic bomb which would win the war for them, never mind where we were. We could be at the doorstep of Berlin, but if they'd had a bomb which they could drop on London and on Moscow at that time, the war would have been over. And that was a race that no one who was loyal to the human tradition could afford to lose. Came 1945, came the question of the bomb is now made, the Germans are defeated, what shall we do? Szilard, Wigner, everybody at Los Alamos, many scientists at Los Alamos, wrote a round robin saying, there's no justification for dropping it on the Japanese. There's no danger of the Japanese making one. They were all in favor of a demonstration on a desert island, such as the famous demonstration back in July 45 in the Nevada desert, in which the Japanese would be shown what the bomb would do on Japanese cities and would be asked to surrender. It wasn't the scientists who dropped the bomb. And that's a distinction which I think all my listeners must understand, that making the bomb was one step, dropping the bomb, and particularly dropping it on the Japanese, was another step.
I think a lot of people really can't accept that statement that you've made, even now. They say these beggars shouldn't make things like that to put in the hands of people who do drop them.
Well, I will make one last attempt to argue against that point of view, and then I'll give up, because it's a question which will never be resolved. I can only say to the young, and to anybody else who wants to argue this, how can you come to me and say, you, me, shouldn't have made the bomb? Because it allowed beggars like those in Parliament to use it. Who voted for the chaps in Parliament? Who put them in? Who elected the MPs? Nobody elected me. I became a scientist by my free choice. But whether a bomb dropper or not sat in the House of Commons, that was the choice of the chaps who voted.
But that makes the responsibility of the voter to learn what it's about. He has
Of
to learn
course.
what power he's voting about.
Of course. And you and I are sitting here because we recognize that responsibility, have recognized it, as we said earlier, ever since the 1930s, and have spoken out as loudly as we could since then. You understand, I wouldn't have liked to be a politician either over the Japanese issue.
There's a word that people use a lot, and I think the young use it, perhaps they always did, which is ought. People ought to do certain things. They ought not to do certain things. And yet there is in, I think, 20th century science, this fundamental patterning of the universe. The idea of things ought has gone out of the window somehow. It is surely that things are thus and so, and that you cannot expect the universe to do things that it doesn't do naturally.
The book, Science and Human Values, which I wrote when I came back from Japan, the lectures that I gave then, which caused me to be invited to the Salk Institute and to go to America, deals very much with that question, and I'd like to talk just about this ought and is. Yes, it was very fashionable in the 1930s for people to say, the reason why scientists do terrible things like making bombs is because there isn't any ought in science. Science can only discover what is, not what ought to be. I think that's false, and it's because it's false that all this argument about how scientists ought to behave has come about. There is an ought in science. That's why my book is called Science and Human Values. I wish I'd invented a phrase not so easy to steal as human values, but there it is. It's become the commonplace of the university since then. What do I say there? I say that you cannot discover how the world is until you behave in a way which is calculated to get at the truth. The Germans thought they knew how the world is. They knew that Negroes were descended from apes and human beings were descended from Aryans. They knew that Jews came somewhere in between, and that's how the world is, they said. And if you said to them, that is a pack of lies, you were just liable to be stuck into bunker number 11 at Auschwitz, which was a very nasty place to be in. Dogma about what is as easy to invent as dogma about what ought to be done. Science is devoted to the proposition that the discovery of what is a noble enterprise because it can only be carried out by absolute devotion to the truth. And that's why no scientist could accept the idea that he's to make a discovery and then not publish it, that he is to be both judge and jury. He will always say, and it doesn't matter whether you're talking about bombs or the intelligence quotients of one race against another. If he's a scientist like me, he will always say, publish and be damned, because the human race will only learn how to use knowledge well by having knowledge disclosed on it and the choice thrust down its own throat. If you wish to act well, then you must accept that acting well among scientists is being truthful.
That was the late Dr. Jacob Bronowski in the 6th of 10 conversations with George Steedman.